So I want to do a short little lesson with you on graphing absolute value inequalities. Now listen, the only thing that's going to happen today is that we're going to take what we've been learning about absolute value equations and vertices and shifting, and we're going to throw a greater than or less than sign into the problem. So what does that mean? Well, it means that we're going to end up shading. In other words, adding an extra step where we do some shading. So let's make sure you get the idea. What if we didn't have a greater than or less than sign? What if we had something like y equals the absolute value of x minus 2? Well, the hope is that from the last few days that you're saying, hey, I got this. All I have to do is think about some basic shifting and a vertex, and we should be able to have a graph. Now, do you remember the shifting rules? If you have a minus 2 out here, that's going to shift the vertex down 2. And so I can very easily and quickly graph 0, negative 2. Of course, if the slope is 1, which is sort of like the original slope, it just means that my graph is going to go up 1 and over 1. And of course, it's going to continue to do that as I create the V shape. Or it could do it in the opposite direction, up 1 over 1. And again, I'll get my V shape. So basically, we just get a graph here. Let me get rid of those steps. I don't like all that. Basically, we just end up with a graph, an absolute value graph, that was shifted down 2. Now, that's if we had an equal sign. But what if it really was, say, a greater than or equal sign? Well, the good news is I don't have to change what I just did. I still have the vertex. I still have the slope. All I got to do is think about greater than, which really boils down to a test point. Now, when we think about test points, we typically try to find a point that's on one side of the line or the other. Just so you realize, this would be one side of the absolute value, and this would be the other side. It kind of feels more like an inside and outside. Now, you can pick a point anywhere you want, but most of the time we encourage you to pick 0, 0 if you can. And when you pick 0, 0, that just means you're plugging that in for y and for x. And basically, you're finding out if it comes out true or false. Now, I'm pretty sure I get the statement that 0 is greater than negative 2. Is that true? Well, be careful. Yes, it is. 0 is greater than negative 2, which just means that my test point, or the side that my test point's on, is the shaded side. And so I'm going to end up shading inside, if you will, inside of this absolute value graph. Ready to do another one? Sure. Let's take a look at something like y greater than the opposite of the absolute value of x plus 2 plus 6. Looks a little bit more involved, but hey, remember, the good news here is that all we really have to do is add the concept of shading to what we've already learned. So, plus 2 on the inside, remember, that's a shift to the left. Plus 6 on the outside, remember, that's a shift up 6. So we're basically going to go 2 units to the left and 6 units up. And if I go 2 units left and 6 units up, I'm pretty sure I land at the point negative 2, 6. Now, you always want to label that point. Next, we're going to use the slope. The slope is negative 1, which really means that the absolute value graph is going to open downward. And the truth is, I don't need to get real specific with actual points. All I really need to do is just draw a line that goes, or excuse me, a V shape that goes down. Now, I have to confess that I made a little mistake. I was getting excited about making the graph open down, and I forgot that this is just a greater than, in other words, not equal to. So, you need a dashed line. Oh my gosh, we need a dashed line. I'm going to have to go back and do some erasing, which I always hate to do. It's easy to do on the iPad here, but yeah, we need a dashed line. All right, now we're ready to think about a test point. Now remember, test points just need to be on one side of the absolute value. It looks like 0, 0 is definitely going to be on one side. Are we sure? I think we're sure that it's on the inside. So what I can do is I can plug 0 in for x and for y. And when I do that, I got to carefully work out what happens here. It looks like I get the opposite of the absolute value of 2. The absolute value of 2, of course, is 2, so the opposite of that is negative 2. And when all the dust settles, I get 0 is greater than 4. Is 0 greater than 4? No, it is not. That doesn't mean I made a mistake. It just means that I'm going to shade on the other side of the test point. The other side of the test point ends up being the outside of this absolute value graph. So really, I would try to be shading everywhere on the outside, kind of running out of space up there, but that's going to be your solution. Now remember that that shaded region is the solution, and that's why, of course, we are making a shaded region. Again, the shaded region is the solution. Let's do one more problem. This one looks a little bit more involved. It's a system. Uh-oh. What do we do with a system? Well, we look for the intersection of the shaded region. The intersection of the shaded region. Okay. Well, you got to still graph one at a time. So we've got a graph that looks like it shifted to the right 4 and up 6. So we can plot that point as 4, 6. It does have a slope of negative 2, so I'm going to go down 2 and over 1. If I do that a couple times, down 2 and over 1, I'm going to, that's interesting, I didn't know it could do that. I'm going to end up with a V shape that is opening this way. So looks like I can take care of that first graph. No need for a dotted line, right? No need for a dotted line. Now the next equation, careful, that's not an absolute value graph. Oops, sorry, we need to do some shading, don't we? We need to do some shading. To save a little bit of time here, my test point once again would come out false, and so that means I'm going to end up shading in here. Now, I'll tell you what, I don't want to make this too messy, so I am going to erase that, but just keep in mind that we are shading in the inside right now. All right, now it's time to graph the second line, which is a line, right? It's a line that has a y-intercept of negative 8, and it has a slope of 1. A line that has a y-intercept of negative 8 and a slope of 1 is going to be a diagonal line. A diagonal line, not a V shape, but something more like that. We also have to shade on for that line. And to save a little bit of time, if I shade on the blue line, I'd be shading on the true side of my test point. It would come out true. Now, where's the intersected region? Where's the intersected region? It would be the part that has both shades. And of course, that actually ends up being on the inside here. Don't assume that it's on the inside, but that is the case for this problem. Now, whenever you guys are doing a system, we're always interested in the corner points. Now, it looks like one of the corner points is already labeled. That's nice. But what about these 2 points? Well, even if we had graph paper and we were really careful, we may have trouble exactly finding those. So instead, what we're going to do is a little algebra. What kind of algebra, you ask? We're just going to take our 2 equations that are both equal to y, and we're going to set them equal to each other. Check this out. We're going to take both equations, the absolute value equation, which is equal to y, and my x minus 8 equation that's equal to y. We're going to set them equal to each other, because when you do that, you're finding when the 2 lines are equal. We call those intersection points. Now, what did we just make? That's right, we made an absolute value equation. An absolute value equation like a number of weeks ago that we solved by Well, by trying to isolate the absolute value. So we have to do some stuff like subtract 6 from both sides. We have to do some stuff like divide both sides by -2. Now, when you do these things, you end up creating an absolute value of x minus 4 that's equal to -1/2 x plus 7. I know we get a fraction, but the whole point here is that this equation is now able to be split. And we're going to have to split it so that we can solve it for these x values. Now, I'm running out of a little bit of space here, so I'm going to have to transfer to another page. Let me grab this equation again. It was the absolute value of x minus 4, which happened to equal -1/2 x plus 7. And as we said, it's time to split it into an equation that's equal to the same thing. Of course, when you're equal to the same thing, you're equal to -1/2 x plus 7. You also want to break it into an equation that's equal to the opposite. Now, the opposite is going to switch both the signs, so now I have a positive 1/2 x minus 7. You got to solve these. And again, you got to kind of get over the fact that we have some fractions. Just got to get over it. We're going to solve these. We're going to add 4 to both sides. That gives us x equaling 1/2 x minus 3. And then you just want to subtract this 1/2 x over here. And that's not that bad. If you subtract 1/2 x from x or from 1x, you get 1/2 x. Now, if 1/2 x equals -3, then x equals -6. Over here, if I add 4, you end up with 11. And then when I add, this time I have to add 1/2 x. Well, you're really adding that to 1. And so we end up with 3/2 x, or 1.5 x. But when you solve that, you can multiply by the reciprocal. When you multiply by the reciprocal, you do end up with a little decimal. It's not the end of the world. You end up with 7.33. Now, remember what we're doing. We're trying to find points. Just so you realize, all we have right now are just x values. But the cool thing is I can take those x values and I can plug them back in for x so that I can get the y value. So I'm going to plug in -6, and I'm going to plug in positive 7.33. And we'll plug both those in for x. And when you do that, you get the y value that goes with it. This one, you end up with a y value of -14. And this one, when I subtract 8, I actually get like just negative 0.66. And that's my y value. Guess what these 2 points are? That's right, they're the points of intersection from our system. And so ultimately, I want to label those points of intersection. It should be part of my final answer. And they actually kind of look like they're right, even though, again, we didn't use graph paper. I feel pretty good about the value of these points. So what's our solution to our system? Remember, the system was this original thing that I was given. Well, the solution is the shaded region with the corner points. Now, that little lesson has a little set of exit problems. And what you want to do now is you want to use the back of your paper to perform each of these 3 problems. It looks like the first one's going to be y greater than 2, the absolute value of x minus 3 minus 1. That's the first one. The second one is going to be y greater than or equal to negative absolute of x plus 2 plus 6. And in the last one, you're going to try to write an equation for the given graph. You're going to try to write an equation. That kind of looks a little bit like what we did in the warm-up. Now, if you want to try the bonus problem, you're going to have to get that from me. It looks like that bonus problem is going to be a system. Just ask me for it when you come to class, and I can share that with you. To be honest, I just found it. So that's going to be y greater than the absolute of x minus 4 and y less than or equal to 1/2 x plus 3. Notice that that's a system, so it's going to be kind of like the last problem that we did. Have fun coming up with that shaded region and those corner points.